Our assigned region is Yorkshire and Hamburg. The county has a largely mixed economy and the largest cities are Sheffield and Leeds. Northern Yorkshire has remained an agricultural area but has established a tourist industry, specifically in Leeds. High-tech facilities have also clustered in Yorkshire and brought in significant investment to the region. Sheffield was originally based on coal mining. However, the industry has declined and the area has become a center for specialist engineering. Our objectives are to evaluate and analyze the travel-to-work areas of the region so that we can determine which areas are performing economically weaker compared to the rest of the region. The basis of our information was unemployment data and sector growth. Our main research questions are: to what extent do economic disparities exist in the region? Which areas are more economically depressed and which are better off? Does specialization exist in each of these areas? Which travel-to-work area is the best candidate for investment? In processing our data, we came across a few obstacles, including missing pieces of information. This limited our ability to fully analyze the unemployment rates and sector growths for each industry and aerial unit. The data facilitated our research process and provided a basis on which we could calculate location quotients, shift share analysis, and delimiting our region.
Oh, didn't see you there. In order to delimit our policy regions, we've decided to use a two-dimensional approach. The dimensions are job growth rate and unemployment rate. Why are these dimensions relevant, you might ask? Job growth rate is important because it shows how employment varies from different years, which portrays how growth as a whole is occurring. Unemployment rate is important because it shows how efficient the economy is when it comes to employment. Some pros of this method is that it accounts for more than one criteria: job growth and efficiency in the travel-to-work areas' economies. This is beneficial because lower unemployment rates indicate more efficiency and a higher job growth indicates a growing economy. Limitations of this method are that job growth rate and unemployment rate are assumed to be the best measure and does not take into account other measures of performance. This method is also sensitive to scale and availability of data, since data is not always gathered at both dimensions or scales. Looking at this graph, we can see that the top left quadrant shows poorly performing regions and bottom right shows well-performing regions. Green represents the best performing and red the worst, which are Hawes and Leyburn and Calderdale respectively. To find these, the standard deviation for both unemployment rate and job growth rate were calculated. These were then converted and plotted as z-score values. The absolute value of the sum of both the x and y values were used to portray the best and worst travel-to-work areas. Our rationale for choosing a policy region was to choose the poorest performing region and select it as our focus, which was Calderdale. Historically, Calderdale has focused on creative industries, manufacturing, green industries, and health, which, as you can expect, are primarily located in secondary and tertiary industries.
From 1995 to 2002, the employment structure of the area has changed substantially. Though there is an issue conveying the small change in primary industries, the shift in secondary and tertiary industries are very well represented on the graph provided. For the region as a whole, the graph displayed illustrates a near equal shift in employment from the secondary to tertiary sector. In the well-performing areas, employment shifts follow a similar pattern, though on a less drastic scale as compared to the region on the whole. These areas are characterized by a slight drop in primary employment, a decrease in secondary employment, and a near proportional increase in the tertiary sector. On the other hand, the areas of poor performance experienced a shift in employment similar to the prosperous areas, though on a much more volatile scale. With a 6% increase in the tertiary sector, this was matched by a near 6% decrease in the secondary sector. While the information gained on employment is useful in determining general trends in employment shifts and distribution, this data must be supplemented by additional data and analysis techniques in order to draw substantial conclusions. To meet this requirement, we have further examined the area using the location quotient technique. While there is an issue representing the small change in the primary sector, the change in employment of the secondary and tertiary sectors are well represented on the graph. While we considered graphing the sheer percentage change of employment in each sector, in doing so we realized that the magnitude may be misinterpreted by those viewing the graph. To meet this requirement, we further re-examined the area using the location quotient technique.
We calculated the location quotients for 1995, 2000, and 2002, excluding 1991 due to a large number error. Overall, our well-performing TTWAs were specialized in the service-oriented industry, while our poorly performing TTWAs were specialized in the manufacturing industry. Our worst-performing TTWA was Calderdale. In 1995, Calderdale was only specialized in the manufacturing industry, while in 2002 it made a small shift towards banking and other services industries. Hausen-Leyburn was our best-performing TTWA. In 1995, Hausen-Leyburn was specialized in the transportation and communication industry, as well as 3 other industries. In 2002, Hausen-Leyburn was strongly specialized in the other services industry, making the TTWA shift from diversified to centralized. During our initial analysis, we calculated the Hirschman-Herfindahl Index, regional industrial diversity, location quotients, and shift share analysis. Further analysis showed that the scope of our study focused primarily on data acquired by location quotients.
I will be speaking about the economic base model and the local economic forecasting. The selected TTWA within our region was Calderdale. The selection of Calderdale was really dependent on its position on the Z-score graph. Calderdale demonstrated the highest levels of employment while preserving the lowest levels of growth. The use of 2002 data provided the most up-to-date information for providing basic and non-basic description for sectors. To classify basic and non-basic industries, we established standards for the location quotient. Anything below 1.0 on the location quotient was contributed as non-basic sectors and really only for domestic needs. Anything above 1.0 was contributed to basic employment and really perceived as export-oriented activity. This graph demonstrates our findings for basic and non-basic employment in Calderdale. As you can see, basic is indicated by red and non-basic is indicated by blue. There are 3 sectors demonstrating basic employment. These 3 sectors are C, manufacturing, G, banking, finance, insurance, and I, other existing industries. The use of the unemployment rate and growth rate would be used to investigate the impact of investment and evaluate the increase of 10% in the basic sector. This would also enable a level of consistency for evaluations of all other TTWAs. In addition, the use of Z-scores and location quotients would be duplicated to compare the transition of Calderdale in comparison to its previous position and other TTWAs. A newly generated multiplier effect would enable us to analyze the effects of a 10% increase in basic employment and investigate any spillover effects into other sectors. We've calculated the multiplier effect to be 1.92, and an effect with a 10% increase in the basic industry equals a total of 2,021 jobs introduced into Calderdale.